Good afternoon, everyone. Really pleased to be here today, and I'm going to take you on a bit of a journey that I've been on for the last 10 years or so with an open source project called HILTOP, which stands for Hardware in the Loop Test Operating Platform. So let's make a start. So just a quick agenda, who we are, where did I come from? HILTOP, what is it all about? What does it do for you? What problems does it solve? We're going to do a deep dive on the hardware. We're going to talk about what's inside at a low level, the backplane architecture, and then some of the software tools we've developed to go with the HILTOP, and then finish off with some case studies and how you can get involved in the project. So, like all good startups, we started in a garage about 10 years ago, and some of the early test solutions that we were developing here on the top left, which were based on like media PC cases. And at the heart of that solution was a motherboard, an ATX form factor PC motherboard that would fit in a standard PC case. And it was powered by Raspberry Pi. So we're going to pick up on Raspberry Pi again, following on from Adam's talk. And we've been a Pi fan for a number of years, and we've used it in our products since the early days. And then you can see the latest incarnation there in the bottom corner, which is the current day HILTOP product. So a bit about my background and my company, DevTank. Our expertise is test and measurement, and we're hardware and software specialists. Been sort of providing open source technology solutions to businesses for a number of years. And we've got a very open source approach to development. So the tools are important. So all the tools we use, nearly all of them are open source in our company. You'll recognize some of the names there. So for hardware design, KeyCAD and FreeCAD are the top hitters for us. So all the electronics, PCB layout, schematics are done in KeyCAD. FreeCAD is used for our mechanical modeling and assembly generation and making sure all the parts fit together, that kind of thing. And then we've got data, SQL and Grafana used for visualization. And we've got a number of software tools we're using. So we're making open source products with open source software and hardware tools. So the HILTOP, what's it all about? What do we use it for? So some years ago, we realized that businesses need an alternative to all the proprietary solutions out there. When it comes to test and measurement, they need a product that they've got easy access to, so they can see what's going on behind the scenes. They can fix problems easily, because when let's say you're testing a product in a factory on a shop floor, and it's a product you designed. If you've got a bespoke test solution that you're using to test that product, you don't know when there's a fault, whether it's inside the test solution or whether it's the product itself that's at fault. So an open solution provides full transparency, and that's what we're doing with the HILTOP platform. So really, it's an industrial computer. It's an I/O industrial computer platform, and it solves problems for businesses and industry in the world of test and measurement. It's automated testing, it's hardware in the loop, it's regression testing, functional testing. You get the idea. So it can do all of those things. So what's inside? So at the heart of the HILTOP is a Raspberry Pi based motherboard. So this is an ATX form factor motherboard. You can see the CM4 processor that we use there, the Raspberry Pi processor. We're running obviously a form of Linux on here. It's Debian based Linux that we use for the operating system. We've got expansion headers for various boards that you can buy off the shelf, the Stemmer, QT, the Quick boards, the Micro form factor plug-in boards. You can use all of those. And we also have a backplane standard that we've developed over the years called OpenVTI, and I'll talk more about OpenVTI in a little while. So that motherboard is the heart of the system. It's got an adjustable power supply. So often when you're testing or controlling someone else's product, you need to develop some form of DC power supply to power the device under test. So we've got a software controllable DC to DC switch mode power supply there, which is a homebrew design I came up with some years ago, and it seems to work quite reliably, so we've stuck with it. It can provide up to 3 amps of power to the load that you've got connected. We've got fan controllers, because obviously if this is going inside a case, you need to think about cooling and heat sinking, so we can plug in standard, PC type 12-volt fans to this platform. It's got hard drive connectivity, so we're using basically the CM4 capability and PCI Express, a single channel to bridge to USB 3. We're also bridging to USB 2, which goes off to our backplane connector here, the OpenVTI connector, and off to the back panel. So on the back panel, you've got all the standard PC type peripherals that you'd expect to see, like USB, gigabit LAN. We've got HDMI, 4K HD video output, and the image generally runs on an SD card. So you can see the SD card holder there on the back, the top side of the board there, so it's exposed to the outside world when it's fitted inside a case. The whole platform is kind of designed to be developer friendly. So it's open hardware, open software, and it's developer friendly. So you get the idea. We want sort of people using this to really adopt it and run with it. And when there's a problem, they need to be able to fix it and diagnose what's going on. You can't do this with proprietary hardware in most cases. You're lucky to get the schematics, and you're especially lucky to get the layout files for the design. And we've also got things like touchscreen outputs and camera connectivity for a CSI form factor camera, which anyone who's played with Raspberry Pis will be familiar with. So this sort of picture shows you what's inside the HILTOP chassis. These are the main parts. So we've got an OpenVTI backplane plugged in here, some modular cards, and then you can see the motherboard here laid flat. So that's what it looks like as a system. The plug-in cards generally have their own microcontroller on them. So low-level firmware runs on the actual plug-in I/O modules, and these modules do different functions depending on what it is you want to do with the HILTOP platform. So we've got some that are dedicated for sort of ADC, lots of ADC channels. We've got some that have adjustable power supply outputs, that kind of thing. We've got some RF cards. It just depends what you want to do with the solution and what problems you're trying to solve. And as an adopter or user of this platform, you can develop your own cards. We published the standard for the OpenVTI connectivity on the backplane. It's very developer friendly. You can buy a Eurocard from all the usual component suppliers like RS and Farnell. You can prototype your own I/O card, expansion card if you wanted to, and plug it into the chassis very quickly and easily. And again, you can't do this with proprietary locked hardware solutions. So let's home in on the OpenVTI backplane. So what's on it? Well, a number of things, but generally what we're doing here is we're using USB 2 for the payload. So the modular cards that plug into the backplane use USB 2 for the primary payload and for field programming. We've also got things like SPI, I2C. We've got a number of power rails that come out to each backplane card connector. And we've got LVDS bus. So LVDS is high-speed differential pairs which convey data and clocks. And they're used for sort of parallel processing type functionality. Perhaps you've got a couple of cards doing a dedicated job and you need to get the data off the cards very quickly, and you maybe need to synchronize the data between multiple I/O cards. So the LVDS bus might be used for that. And you might have an FPGA plugged into the backplane, which does all that arbitration and synchronization of data. So it's quite powerful sort of architecture, and it's built loosely on the PXI. I don't know how many of you are familiar with test platforms. And there's a standard out there which is called PXI. PXI has been around for a long time. It's used by companies like National Instruments and various vendors that make PCI chassis and card solutions. This is like a kind of cut-down version, if you will, which is designed to be very developer-friendly. It's easy for engineers to pick up and create cards very quickly and use the open source sort of ecosystem that we provide. A bit more about the plug-in cards. So that's just a summary, really, of what's on each card slot. So you can see We've got all the usual things you'd expect to see on an embedded kind of product, ITC, SPI, PWM. We've got shutdown lines, reset lines, and triggers that you can use to synchronize cards. We've got a number of power supply rails there that you can use. And we've got the LVDS bus I mentioned earlier. And then, of course, the DC programmable power supply comes out to each card slot. So you might want to use that to bring out to the front panel, let's say, so you can plug in some kind of device under test. And it uses the DIN 41612 Eurocard connector, which is an industry standard. Again, it's very easy to buy off the shelf. You can buy it from component suppliers, and it's readily available. So low-cost kind of hardware that you can bolt together quite quickly. So we've got this story about a persona called Howard. Now, I'm sorry for anyone called Howard in the audience. So Howard is a kind of disgruntled test engineer that works for some kind of manufacturing business. And they're mass producing some kind of electronic and software device or multiple devices. Howard has to manage all the test systems in the factory. And he's got a mixture of cobbled together solutions over the years that he's had to support. Some made by other people, some made by him, some made from Raspberry Pis and Arduinos. You get the idea. So you see this, and I've seen this when I've walked into a number of factories over the years. It's a maintenance nightmare. And some solutions have been bought in by that customer or that company, and they're proprietary, they're locked down, you can't see what's going on inside. So step in an open source solution that Howard can potentially use to solve his problems. So what we like to say to people is that we're trying to break that make versus buy dilemma. It's as though, when it's open source, it's as though you made it yourself, but you didn't have to. So you've got the same access that the authors, the creators of that equipment have, which means that there's full transparency. So you can very quickly buy some open source hardware like this with some kind of maybe test fixture, so you can plug in a PCB or the device under test that you're trying to control or test. Very quickly put together a solution which gives you, transparency, traceability. It complies with safety requirements, and it's efficient. You're saving a lot of time. Someone's done all the hard work for you. You don't have to reinvent the wheel, and we're all about not reinventing the wheel using open source technology. When I started with my current company about 10 years ago, we were just doing consultancy and using other people's solutions, and it wasn't open source, and it was very hard. Every job was different. Every job took a lot of work to turn a handle on and develop some sort of custom, equipment for that customer. And so we realized early on that there was a growing need for some sort of open source ecosystem, and that's what we've developed here with the HILTOP platform. And we've developed a number of plug-in modules over the years and accessories. So one of the target markets we've been working quite proactively in is EV charger manufacturers. So we helped a number of EV charger manufacturers do volume testing of their products. And I'll move on to talk about some of those case studies shortly. So there's no good hardware without some sort of good supporting software. And we developed some open source toolkits over the years that go with the HILTOP. The first one is ProdTop, which is all about production test and automation. So it's designed to be very operator friendly. There's a barcode scanner that the operator generally uses to scan a QR code on the device under test. And then our equipment takes over. It runs a series of normally Python-based test scripts which control the hardware, read and write, provide stimulus to the device under test, that kind of thing, and then record all the results into a database. And then LabTop is more focused on laboratories doing R&D type testing, where you might want to control some hardware, you might want to graph the results in real time, run experiments, that kind of thing, university labs. Anywhere where you're doing sort of R&D hacky type development work, you might want to use the LabTop kind of open source software. And then just to finish off, so we covered hardware and software. Now you need data. So you need to look at what the data's telling you. So this is where some of the open source toolkits come in. We use Grafana to display all the data that we store in SQL databases. So our customers can kind of see pass and fail rates, first-time hit rates. They can look at individual test points that have been monitored for like voltage and current levels. So you can see on the graph here, you've got the pink band, which is like the pass band, if you like, for a particular measurement. So you can obviously see how many times it's failing and how far off it is when it does fail. So all of this data is tracked since the testing started. So you can look back over time and you can improve, and you can improve your pass rate and get the yields up, which is all value added for the customer or the user of this. So I'll just finish off with some case studies. So I mentioned EV charger testing. So just some examples of where we've used this sort of open source ecosystem. So on the pictures at the bottom, you can see motherboard level test fixtures where we're testing the circuit board in some kind of bed of nails fixture. And then the bottom right is like an end-of-line test rig where we're faking the electric car and the HILTOP platforms inside that black box, that rack, alongside with a big load bank. So the load bank is put in full load power through the electric vehicle charger, pretending to be a car and emulating all the vehicle protocols at the same time. And all of these test systems are linked together, so they're all networked generally on site, and the customer has all the data going into a common database, so they can query when a device fails at the end of line level. They can go back and look at all the test results at the PCB level and link the two together, and they can see how close it was to its margins, its pass-fail criteria, that kind of thing. So it's very, very powerful when you've got all of this kit networked and you've got access to all that data, all that hardware and software. There's full transparency. And it's come back to bite us a few times when there's been a problem. We've been working on a customer job, and there's been some sort of, is it you, is it us, what's going on? And that open nature of how we work and how the HILTOP works means that it's very easy to say where the fault is and debug it. Another example a few years ago was we were working on a space job, a satellite test job for OneWeb. So OneWeb was a big space project where they were trying to roll out a cluster of satellites over certain parts of the world to provide internet coverage. And we were involved in some of the PCB assembly testing. So we were actually provided by the customer a number of these jigs that you can see in the picture here with some connectors, and we were told to make it work and provide some kind of automated test equipment. So that's where the HILTOP came in, and we developed some custom I/O cards that worked with the customer's boards that we were testing. And we were also controlling, RF test equipment. So there was a number of legacy bits of RF test equipment that we had to connect to, because RF test equipment, for those of you who know, it's very expensive. It's hard to replicate some of that functionality. So we wouldn't dream of trying to develop our own modules to do some of the tests, spectrum analyzer type functions or VNA type functions. So we recycled a load of old test equipment, and we were like the central controller, taking all that data from that third-party equipment, putting it into a common database, and then doing the bits that we could do, like the electrical testing, the functional testing alongside. So it's very powerful. You can build quite large solutions quickly when you've got, a Lego toolkit at your disposal. The final case study was an autoclave control system. So this particular customer wanted to develop a sort of brand new control system, and they sort of came across the HILTOP platform, and they said, well, rather than starting from scratch, can we use your HILTOP? Because it did most of what they needed. So in this case, it's basically a pressure cooker. The autoclave is used for the oil and gas industry to do corrosion sample testing. So they put sample of metal in a pressure cooker effectively and run it for several days, high temperatures and pressures. Then they take that sample out and they do material analysis on it. So we built the sort of custom control system based on the HILTOP, and then rebranded it for that customer, because you can do that with open source. Again, it's very hard to do with a proprietary solution. So having this sort of Lego equipment at your disposal gives you a huge leg up if you're a customer or any kind of user adopter. I think that's all I've got. So there's just some useful links there. I mean, the next step for us is to start getting more of a community around our products. And the Hilltop, we really want to get more developers contributing to it. And so I'll throw it over to the audience in terms of, okay, any ideas from you folks in terms of how can we get more engagement from the developer community onto the Hilltop platform and get other people using it? Because we think we're onto something. You know, our customers like it, but we're kind of slightly missing that open source community angle, and we really want to try and build on that going forwards. So I'll kind of leave it there and open the floor to any questions. Anyone got anything?
So you said you wanted to encourage people to contribute and play with it. How would I go about getting one?
Okay. One of the slightly problematic aspects of what we do is that it's business focused, so it's quite expensive equipment. Although you can buy a Raspberry Pi for like £50, that's not the case with our equipment because it's not targeted at that audience, right? And actually, a test engineer wants a fully fledged EMC qualified bit of equipment that they have on the shop floor in their factory. They don't want just a low cost single board computer necessarily. They want the full solution. And so there's that quandary of how do we get our hardware into the hands of developers, like yourself. It's a difficult question. Maybe we can raise some funding and actually get our equipment into universities and test labs, academics, and those kind of institutes, because that's where you're going to potentially open doors to the community. Maybe run some competitions, some hackathons, that kind of thing.
Yeah. But also how do I word this? If I did have a budget to get one, would I come to you or would I go to the design files and?
Well, what we tend to find is customers like the idea that it's open and they can do it if they wanted to, but they don't want the hassle. They sooner just buy a solution, right? But that open source side opens doors and it breaks down barriers.
Thank you very much.
Thank you. Any more questions? All right. Thanks very much for listening.